McDonald and I work with Minnesota's coastal program at the Department of Natural Resources. I really do want to thank all of you for joining us here today and for spending this 1 hour of your time to hear the latest update on climate observations and trends in Minnesota. Today's climate conversation has the largest number of people registered that we've ever had in more than 8 years of climate conversations. I know people are still filtering in right now, but this attendance speaks to substantial interest in the topic. Each of us, I think, who have the interest and who take the time to learn more are part of the fabric of resilience. We each have something unique and important to bring to the awareness and action required for community resilience. So again, thank you for being here. These climate conversations highlight topics related to climate change, impacts to the Western Lake Superior region, and offer inspiration for adaptation, mitigation, and resilience. Behind the scenes, we're a collaboration between the Coastal Program, Minnesota Sea Grant, the U.S. Forest Service, City of Superior, and 1854 Treaty Authority. And these events happen because of great teamwork. With that, I do want to introduce to you the newest member of our planning team, Steve Shire, representing 1854 Treaty Authority. Steve?
Yeah, thanks, Julie. I appreciate that. Hi, everybody. My name is Steve Shire. I am the climate specialist for the 1854 Treaty Authority out of Duluth, Minnesota. I've been here since about the end of June, and my main responsibilities here at the 1854 is updating and implementing our climate action plan throughout the ceded territories, which is also known as the Arrowhead region. So thank you.
That we are going to let Kenny offer his own kind of bio and background, but it's now to you, Kenny. Take it away. Maybe you need a minute to...
Hi, everybody. I'm Kenny Blumenfeld. I'm a climatologist with the Department of Natural Resources. I am a kind of the person who does most of the climate change science outreach for the department in terms of helping people understand what's happening with Minnesota's climate. And that's essentially what I'll be doing today. I'm for the most part, a lifelong Minnesotan. I've moved around a bit. I am definitely a lifelong weather and climate enthusiast. So I feel as difficult as this topic can be sometimes, I feel really lucky and fortunate to have the job I have, working in an area that I have kind of always wanted to work in. So thanks, everyone, and I appreciate you all being here. Let me know when you want me to start, Julie.
I'd say go for it, Kenny. It's all yours.
Okay, we'll do that. Just bear with me while I get into presentation mode and make sure I can share the screen also.
Sounds good.
Okay. Start at the beginning. Select screen.
I'll let you know when I see the slides.
Do you?
I'm seeing you. There we go. It's coming up now. Yep.
Okay. Great. Excellent. Well, thanks everyone. So, yeah, I guess I've been providing more of a provocative, or hopefully it's provoking some thoughts for you, title, rather than just if you've seen other talks I've given where we just do kind of climate trends or understanding Minnesota's changing climate. And one of the reasons is that in the past few years, we've had some changes in our immediate hydroclimate. It's unmistakable, right? Minnesota has fallen into multiple episodes of drought. And we have gotten a lot of requests. People have wondered if you were, and I don't presume you have, but if you had seen any presentations from us in DNR that I had given. I've spoken with this coalition a few times in the past, especially through the 2010s. You saw that we were emphasizing, the area was getting warmer with warmer winters. was getting wetter with more precipitation and heavier, larger extremes, and that there were projections indicating that these changes were going to continue. And then we fell into drought, and I think people got maybe confused, because you have to remember climate is a long term. We're talking long term, and in order to have a trend, uh, you really need long-term persistent behavior to establish that trend. In other words, the reason we say all the trends point to we're getting warmer and we're getting wetter is because we have decades of evidence that the climate has been pointing in those directions. And we try and remind ourselves, and we try and remind the people we work with, that climate's going to go up and down all the time. It's going to have what you might call interannual or interseasonal variability, just those ups and downs, but that predominantly we've been getting warmer and wetter. And one of the things I'm going to talk about today is that even in the drought that we've had, that's sort of dominated climate news here in Minnesota for the past few years, you can still see signs that we're getting wetter. And in fact, the trend towards wetter conditions has continued. So I know there's a lot of people in the audience. I kind of looked at the participant list. A lot of names I recognized, some who I didn't. Some of you come from backgrounds in science, some of you are in policy, some are state employees like me. So I probably can't make every single person happy today, but hopefully you can get something out of this discussion. Okay, so I will move on. So the purpose today is to discuss our changing climate. We're going to emphasize again that the warming trend of the past several decades continues. And there's really, we haven't gotten any pushback on that. Every winter when it gets cold, someone asks me, "Are you sure?" Yeah, we're sure. Again, we're going to emphasize that the dry early 2020s actually shows evidence of a continued wet trend too. And I know that sounds mind-boggling, right? I mean, how could this possibly be? So we're going to talk about that. We'll talk about other things, but in short, I mean, the take home is that the regional climate trends really haven't changed. We've been experiencing an expected variation from the very wet regime that we had in the 2010s. But even when you look at that variation and the dry conditions, you can see signs that the wetness has continued. So we're going to dig into that a bit. All right, so let's start with some facts. Let's remember that Minnesota is a naturally extreme climate with high variability. And that you could just look at that graph on the right, which is showing annual temperature and precipitation. If you can see that blue background, those bars, that's annual precipitation averaged around Minnesota. You can see, no 2 years are alike, especially no 2 consecutive years are identical. And then imposed over that, you have the trace of the annual average temperature across the state. And so a few things should jump out at you. One is that from any one year to the next, there's a lot of movement, lots of ups and downs, and that the ranges in those ups and downs is quite large. I mean, the difference between a really warm year and a really cold year can be something like 8 degrees Fahrenheit. And that's huge, especially when you think of what that must mean for the individual seasons or the individual days within those seasons. So we have a naturally extreme climate with a lot of variations, meaning we have no right to expect what we got last year replaying itself this year, or what we experienced this year replaying itself next year. And we also have a lot of weather hazards. We have, anything, you name it. We have drought, we have heavy rain, we have tornadoes, we have blizzards, we have large hail. We get a lot of exciting and also hazardous weather. Another fact is that the human greenhouse gas emissions cause global temperatures to rise, right? We already had some greenhouse gases in the atmosphere. That's why we have life on the planet. But by burning coal, oil, and gas, we have released additional greenhouse gas emissions, and in response, global temperatures have increased. We're not going to dig into the science of that because it's not disputed. And you have to keep in mind that those human greenhouse gas emissions, that excess heating that have resulted from human activity, are really the cause of almost all of the long-term warming for the past century or more. Not exactly all of it, but most of it, the vast majority of the warming that we see. So if you look at the line on that graph on the top there, you see it, the diagonal line. That's the trend of warming in Minnesota going back to 1895. And you see similar trends if you look globally. Most of the slope of that trend is caused by, shaped by the increase in greenhouse gas emissions from human activity. When you look at the short-term ups and downs, most of those cannot be explained by human activity, but instead by natural factors. And it's kind of important to keep that in mind, that when you get a spike to a really warm condition or a really wet condition, or maybe even a really dry condition, it's extremely difficult to just tie that right into the larger changes in the climate. Because here in Minnesota, especially, we have so many ups and downs. So for example, this winter, we're going to break a lot of records this winter. Almost certainly this December is going to break a lot of records around the state for how warm it is. And we know that this is actually behaving very much like El Nino winters tend to behave, especially when El Nino is strong. And that is a natural feature of the climate. And we can look back at historic El Nino events that actually rivaled this one. So even though we know that our winters are warming and that our years are warming, we have to look at these individual episodes. When we look at them scientifically, they're often just natural. But anyway, this is all just kind of establishing facts so that we can move forward in this conversation. Now, when you increase global temperatures, what that really does is it gives everyone more access to heat. Of course, you have to have some way of accessing that heat, importing it. The winds, the weather systems will bring you additional heat. But it also, especially in areas that are, sort of naturally or favor wetness, we have a lot of access to moisture because when the winds blow off of the Gulf of Mexico, we just get uninterrupted or unimpeded moisture from that source. And because of basic thermodynamics, as temperatures rise, so does the rate of evaporation. And what that means is global temperature increases have put more water from the oceans into the air. And so in places like Minnesota, having higher global temperatures has given us both access to more heat and access to more water vapor or moisture. That's, of course, humidity. When you add those pieces together, well, we're getting changes in our local climate. Makes sense. I mean, there's more greenhouse gases in the atmosphere that are allowing the global climate to get warmer, and we have more access to that increased heat, and we also have more access to water vapor. So it makes sense. This fourth point should make sense based on what we've already established here. Here in Minnesota, the consequences are pretty straightforward. Temperatures are increasing, humidity in general is increasing, and precipitation is increasing. And for temperature, it's really especially noticeable during winter and overnight periods. We did have a pretty warm summer, and the past several months have been quite warm, and we've had trends towards warmer summers. But if you've been following Minnesota's climate, you know that winter has been warming on average much faster than summer over recent decades. And that actually ties in with the basics of greenhouse gas physics. But in any case, we're mostly seeing, not entirely, but mostly seeing the big temperature changes when it's coolest, overnight and during winter, and especially winter nights. We've seen more precipitation extremes, that's rain and snow. It's not really discriminating from one season to the next. And another point that we've often mentioned here is that summertime high temperatures. So even though we're getting warmer around the year and we have more access to heat, and we certainly have more access to summertime humidity, our summertime high temperatures and drought severity have actually not shown signs of long-term increases across Minnesota. Not yet. Most climate models are, well, they're all unanimous that we're going to get hotter. And as a result, and sometime in the decades ahead, and then as a result, our drought episodes would probably become more severe once you get into hotter summers where you evaporate more water. I put the next 2 points in just kind of regular font, not bold, because we're going to spend a lot of time on points 5 and 6, and we're going to spend less time on points 7 and 8. But tornadoes, hail, and damaging winds, really concerning events here in Minnesota. They're not actually showing signs of increasing in terms of frequency or magnitude, but they are expanding across the calendar. They're taking up, they're moving into times of year when we didn't used to get them, and they're also expanding geographically. And we've got some examples of that. And of course, we have these kind of emerging hazards as the climate has changed, as our forests become more vulnerable. Here in Minnesota, we haven't seen the kind of spike in wildfire activity that other areas have, and but the science is pretty clear. If you look at recent Intergovernmental Panel on Climate Change publications and even the climate assessment done just recently here in the US, wildfire is going to probably continue to increase in overall frequency and even in severity. And then as a result, the places that are downwind or find themselves downwind from those increasing wildfires are going to have more air quality hazards. And we've started to see some of that. So these are not really established trends yet, but you could think of them as emerging trends. And I've only got a little bit of time to deal with those. So let's just start with temperature and precipitation increasing in Minnesota. So on the right is the graph you've already seen, and it's just one way of looking at annual temperature and precipitation in Minnesota. On the left is another way of doing it, where you could take all of the exact same values and just plot them. So you've got each year's temperature and precipitation averaged around Minnesota, and you could just plot them against the 20th century averages. And so any value, and these are differences from the 20th century averages. So these are basically departures from long-term average conditions. The values in the upper right quadrant represent warm and wet years. The values in the lower left quadrant represent cool and dry years. And you can see that by and large, we're still mostly symmetrical about that axis, meaning that we're just now starting to see, maybe trends away from what used to be the normal climate. It hasn't fully affected the shape of that distribution. But if you look on those highlighted values, these are the combined warmest and wettest years on record. 10 combined warmest and wettest years on record. And if you've seen other presentations I've given, you may have seen different versions of this where I compared what this plot looked like up through the mid 1980s and what it's looked like since then. This is just another way of showing that. But the combined warmest and wettest years on record have all been since 1998. So we have actually shifted, even though it's not every single year, we have shifted into a warmer and wetter climate regime, and it's a fairly pronounced shift. If you look at, this should be familiar to some of you, if you look at the way that temperature has changed, what we're doing here is taking the temperature trend in degrees Fahrenheit going back to 1895, and we're just accumulating all of that change. So on the left is just the average annual temperature change in different parts of Minnesota since 1895. So you see northern Minnesota, where a lot of you are here. That's where we've had the fastest changes in average annual temperature. And the whole state's getting warmer. It's just faster in the north than in the south. That middle view is the overnight low temperatures during winter. So it's actually 90 overnight lows averaged over that winter period. That's December, January, February. And then you're taking the changes in those average overnight lows and you're just accumulating them over time. And what we see is that, a typical winter night or winter morning is now over 7 degrees Fahrenheit warmer than it was at the beginning of the 20th century or at the beginning of this period of record. And that's in northern Minnesota. You see lesser changes in central and southern Minnesota. And then on the right side, you see that summers in northern Minnesota have indeed been getting warmer. These are summertime day temperatures. So those high temperatures during summer, uh, again, that's June, July, and August. And so we have seen increases in summertime temperatures in northern and central Minnesota, but they're not nearly as dramatic with what we see during winter. And you notice that in southern Minnesota, summertime high temperatures are actually showing, these are not statistically significant on the right, but they're showing some long-term decline. And one of our observations has been that even though summertime temperatures have increased on average over the state, if you average those three zones, summertime high temperatures are increasing, they're kind of increasing from the bottom up. We have not anywhere in Minnesota yet observed a significant trend towards more extremes of temperature during the summer. The only exceptions would be far, far northern Minnesota. There are some stations that are just beginning to cross that threshold when you include the most recent summer. But really, it's nothing like what we're seeing in winter, where every part of Minnesota has statistically significant increases in the lowest temperature of the year. I know that's kind of hard to wrap your mind around. So here's an example of what I'm talking about. Here's the average low temperature at International Falls. This is the ice box of the nation. It's a cold weather test bed. And we're going right up through this past winter. So for all our talk about how severe last winter was, it was really driven by how snowy it was. It was a moisture problem. It was not a cold winter. And when we account for even last winter, International Falls average January temperature is now 10 degrees warmer, and that's average January low temperature. So take the average January night and the icebox of the nation, this place that's famous for how cold it gets, and during the coldest month of the year, and those average low temperatures have increased by 10 degrees Fahrenheit. For you Celsius thinkers, that's 6 degrees C. That's a huge increase. So, what that means is, things like negative 40s and negative 30s just aren't as common as they used to be. We've lost the frequency of those events, and we've lost the severity of them too. You could look at something similar. Our favorite climate station in Minnesota is out in the western part of the state. It's called Milan, and it is a rural, essentially almost like a farmstead, and it's three generations of the same family, been taking observations since the late 1800s. And you can see that on the bottom, we have just the absolute lowest temperature of the year. And you see ups and downs along the way, but they've been increasing over time. And if you look at some of the recent spikes, like you see that downward spike on the right side, I'm not sure if you can actually follow my cursor here, but that represents 2019. And that's a extreme of temperature that's pretty bad by modern standards. But if you look left from it, you see how common it used to be. The upper part of the graph is just the average of the 15 lowest temperatures. And, even when you adjust for all the ups and downs along the way, all that normal variability as you go from warm to cool or cold regimes, we still see upward trends in both of these. In other words, what we used to think of as cold is now almost non-existent. And what we now think of as cold used to be pretty common. And we're seeing a general erosion across the state in the severity of cold. Meanwhile, we are noticing that extremes of humidity are beginning to increase. So we don't yet have a lot of evidence that, on any given day, Minnesota is more humid than it used to be. But what we are starting to see is that when we get big influxes of moisture with any major precipitating weather system, or just on a really warm, humid air mass when it comes into the region, the humidity is tending to be higher, and that's manifesting itself as higher dew point temperatures that there's only one time of day where we've had consistent observations at the Twin Cities recording station going back through its history, and that's at the 6 p.m. Central Standard Time observation. And when we look at the highest annual dew point temperature measured at that time, we now have a trend. We didn't used to have one just a decade or so ago. There really wasn't a trend, but we've had enough spikes of over the top humidity events, and we've had these high heat index events. So even though summertime temperatures are not at this point increasing, we are seeing that some of the dew point temperatures are. Sorry, I had to go and silence an incoming phone call there. Hopefully that wasn't too distracting. And here's another example going back to Milan, where there's no clear trend towards sort of worse heat. I know that's a subjective term, but I think most people agree that as we increase summertime heat, although some of us might actually like hot weather and like jumping in lakes, um, it's going to do more harm than good over a lot of our systems, and it's going to cause a lot of adjustments to have to be made. And mercifully, with all the changes that we have observed so far, we just haven't seen yet any trend towards hotter days and the hottest days of summer. So we're not having the number of 90 or 95-degree days has not really begun increasing. We had a lot this past summer, but it actually is plotted. We even have 2023 plotted here, and you can see it on the very far right side of the graph. And you know the highest temperature of summer out in Milan was 100 degrees, wasn't off the charts. And when you look at the average of the 15 hottest days of summer, it was still really in line with historical ranges. So mercifully, we haven't yet gotten to a point where we're seeing increases in summertime heat extremes, at least as measured by temperature. When you factor in humidity, we are definitely starting to see some of those tick up, although it's still a subtle increase that just kind of crossed over into significance. When we look at the projections, and I need to update this because there's new data available all over the place. I just haven't gotten to updating this particular map, but some of you might know that the University of Minnesota has completed modeling studies that have new projections for the state. And there was also a recent national climate assessment that also summarizes some of the climate models. These are unanimous in any scenario that we've ever seen. All models now are unanimous that Minnesota's summers will have more of the kind of extreme temperatures that we haven't yet observed to be increasing. So it hasn't started yet. We don't know exactly when it will start, but sometime in the middle of this century, it's likely. Maybe the trend has already begun, but we just can't detect it yet because we don't have enough years of high numbers of these sorts of days. This map is just showing that even on an extremely optimistic scenario from a couple climate modeling generations ago, uh, even in that very optimistic scenario where policies are robust and countries make agreements and get along and start leveling off and reducing greenhouse gas concentrations, we were still expecting increases in the number of 90-degree days pretty substantially. Most parts of Minnesota would see an increase by a factor of 2 or 3, meaning, in the Duluth area, maybe instead of having 5 to 10 such days in a typical year, depending on how far inland you are, maybe you're up closer to 20. That's a big change. And it implies that, our cooling needs, whether we're talking about natural systems or just where we live, are going to really increase in the summers ahead. Just hasn't happened yet. And I think it's important to expect surprises when we talk about heat. I like showing this won't apply as much to Duluth in terms of these numbers, but the concept does. So Portland, Oregon had a hot weather climatology that resembles what you would expect in parts of Western Minnesota, the kind of the hottest parts of Minnesota. It's highest temperatures on record had been, above 100 degrees with the very highest. I think there were 2 different dates that had hit 107 degrees Fahrenheit. And if you look at this particular chart, there's no trend. I mean, you couldn't find a trend. There's just no way to find a trend here. In other words, there's nothing indicating a big increase in the frequency or severity of extreme heat events in Portland, Oregon. But then in 2021, they sequentially added, they got hotter again, and then hottest. And they, in 3 straight days during a 5-day period, I mean, they had 5 days in a row where they ended up on this chart, and they went in order. So on the 3rd day, they broke their all-time high temperature record. On the 4th day, they broke that record again. On the 5th day, they broke it again. So the high temperature record went from 107, and just 3 days later, it was 116 degrees Fahrenheit. And the question we have to ask is, well, okay, if it could happen there, why couldn't it happen here? And again, in Duluth, it probably wouldn't be quite that dramatic, but it might be. Duluth has had temperatures above 100 degrees. Uh, and so it could be something that you either haven't experienced in a very long time, or something that you don't have any record of having occurred. And this is again because there's more heat. Global temperatures have increased. There's more pockets of heat. There's less cool air around. And when the conditions are right for forming a really hot air mass, those conditions often now have a boost over what they used to have, and they can sort of outperform, and then you get high temperatures. So now we're going to shift over to precipitation. Here's just a look at how the precipitation normals have changed over the United States during the last 100 plus years. So on the upper left is the 30-year average at the beginning of the 20th century, and in the lower right, is the 30-year average or normal precipitation from the current normal period, which goes from 1991 through 2020. And this is kind of the baseline uh, against which we compare a lot of our climate metrics. If we want to know how warm or how wet or how dry or how cool we are comparing it to that recent 30-year average. Now, these values are plotted as relative to the 20th century averages, so kind of similar to that graph I showed you earlier in the presentation. And some of this shouldn't surprise you. We had extraordinary drought in Minnesota in the beginning of the 20th century. That was, something that most of us here, if not all of us living in Minnesota, really have no familiarity with a drought that essentially lasts 20 years. So some of those browns that you're seeing on the map over Minnesota in the upper part of those maps are sort of expected very dry deviations based on what was happening in the 1920s and 30s. You could see that as we got away from the 1920s and 30s, kind of the middle part of this sequence, things became more normal, where you had sort of wet decades, dry decades in different parts of the state. And we went into what Don Baker and other climatologists had referred to as the benign climate period of the middle of the 20th century, where climate was actually pretty agreeable, with lots of metrics kind of near and even defining kind of long-term normals and long-term averages. But then as we got towards the end of the 20th century and into recent decades, we've just gotten wetter, wettest. So the current normal period in our region is the wettest on record. And really the last decade was the wettest on record for Minnesota, which is what this graph is showing. If you look at those kind of the wet periods at the very beginning of the 20th century, and then the dry periods in kind of the early middle part of the 20th century from the drought, and then the recovery to sort of normal climate conditions in the post-World War II period, you really see that from 1895 through 1969, there was no trend, no real increase or decrease in average precipitation across Minnesota. Our climate was actually, despite some of those extremes, behaving fairly normally during that period. And since about 1970, you see an uptick. There's a trend. Now, this trend has been knocked down a little bit, because if you look at that graph, if you look at the plot on the right side, you see three values. The three most recent values are well below that trend line. So if this presentation, 5 years ago, I think our increase in precipitation trend was closer to a half an inch per decade. So it's come down a little bit. It's been knocked down by the dry years, but note that it's still a strongly positive trend line. It still actually satisfies statistical significance requirements. You do have a lot of spread, a lot of ups and downs along the way. So this is why it's important to remember it's just a trend. It does not mean that every year is wetter than the year before. We are always going to have interannual ups and downs or variability. It's just that, what we're seeing is the wet conditions are wetter than they used to be. And one of the things we're going to dive into is that the dry conditions are also wetter than they used to be. And you really need to pull that one apart. Just a little more kind of older evidence now, but this is what we saw as we looked through the end of the last decade and we looked at the largest rainfall anywhere in our long-term stations. What we had was basically, if you look at the bottom of the graph, some evidence of not much change, maybe very subtle increases. But if you look at the top, you look at that pattern uh, where we're seeing with increasing frequency and at increasing magnitude, getting rainfall events, these rare but recordable rainfall events that are coming more frequently and sometimes heavier than we'd had any experience with. So again, it's not happening everywhere every year in Minnesota, but it's really undeniable through a number of different metrics that extremes of precipitation have been increasing. We've even seen some extremes of precipitation increasing during the dry period. I'm going to get to that in a moment. And I won't be able to get to all of them, but there's actually more than we have time to name. This is just one other metric where if you take all of our long-term stations and you assign each station's, you look at each station's 100-year rainfall value for 24-hour rain based on what's called NOAA Atlas 14. And then you just count the number of times that any station exceeded its 100-year rainfall threshold. You see that you're using these current standards, we had not exceeded those values anytime in the 1910s through 1940s. And then beginning in the 1950s, we started seeing events that exceeded the current excessive values for rainfall. And they're still not, they're not happening every year, but if you look at the space between those bars, they're getting more closely packed. In other words, there's less time between them, which actually demonstrates that the frequency of them is indeed increasing. This is just Gooseberry Falls from an event that wasn't even a 100-year rainfall event. I'm not sure how well this will play. Maybe you can see it, but it's Gooseberry Falls after a big Father's Day weekend rainfall event in 2018. Again, it didn't even cross the 100-year threshold, but it was, several inches of rain had fallen. So what we've seen since that very wet period in the 2010s has ended and we've moved into drought is that even in drought, we've had episodes of extreme wetness and flooding. And we're going to actually just kind of walk through some of these sequentially. It's not a deep statistical dive or anything like that. But I just want to show everybody what's kind of shaping some of the trends that we're seeing. So on the left is a picture of the Rainy River flooding. We had volunteers from DNR go up and help with sandbagging and other activities because in early 2022 there was so much snow melt and so much wintertime precipitation and so much spring precipitation that the Rainy River went up to historic levels of flooding and pretty catastrophic situation. Later that summer, different part of the state for sure. Down in the Twin Cities, you can see that Minnehaha Creek ran dry for the second straight year that you could see that. So we've been getting, and this is what I want you to keep in mind, even as we've been our minds have been dominated by drought type considerations, we've actually had episodes of exceptional wetness interspersed with these dry periods, and there seems to be a kind of rhythm to them. We don't know if that's just random and it's just a coincidence or if it's part of a real trend, but I'll show you. I'll just kind of take you through some of these episodes. So here's using one of our climate tools, northern Minnesota, looking at the January through August precipitation in 2021, which some of you might remember is the first year where we had really kind of dire drought conditions from the growing season dryness. And it was especially bad in northern Minnesota. And you can see that the January through August period became the third driest on record. So that's an absolute extreme. You could see from the graph that there's not really a trend towards more of those dry conditions, but we don't want to downplay how dry that part of 2021 was. On the US Drought Monitor, the little image that just appeared, we ended up seeing parts of Minnesota go into what's called D4, or exceptional drought. It's the highest drought level that the US Drought Monitor has. So, and this was the first time since that drought monitor began in the year 2000 that any part of Minnesota had gone into this level of drought. So it was something that, you know, almost a generation of people had not experienced in Minnesota. It certainly was, you know, not a drought to downplay. But following that, I mean, we got into a wet fall for one, but then by winter we just got into this unreal pattern where not exactly the same part of the state, but much of the same part of the state had not just record wetness, but wetness for which there's really no precedent whatsoever. It just destroyed all other records. And this is a long period, December of 2021 through May of 2022 in this part of the state, the very wettest on record. And that corresponds with the flooding that showed images of in the Rainy River area. Here's a graph that just popped up for International Falls' year-to-date precipitation through June 19th of that year. And again, it was a big record, and it was a lot of water. And this again, just think of it, it's on the heels of this really incredible dryness. If you notice where that streak of exceptional drought is in this image, it's touching the International Falls area. So they went from the highest level of drought on record or that can be recorded to, you know, flooding that required people to, you know, suspend their day jobs and go help out and do some sandbagging and emergency response type stuff. And then following that wet period, in southern and central Minnesota, we had the driest June through October on record. Parts of northeast Minnesota were still getting wet during at least part of that period, but by September and October, the whole state went dry. And so that was the fourth driest September and October on record. And once you're in the top 10 for any of these, you're kind of in extreme territory. So you see, we went, you know, dry, wet, dry. Then in the winter, last winter, we had third wettest winter statewide between November and April. That's again a long period. We ended up with essentially statewide flooding, very wet fields. We had farmers who were wondering if they were even going to get in to get their crops in. So lots of ups and downs in the hydroclimate. And then, of course, following that, May through August was the fourth driest on record statewide since 1895. And during that period, areas not far from Duluth went back into that D4, that exceptional drought. So if you look at what the arrow is pointing to here, parts of Carleton, Aiken, and Pine counties were in that worst drought category that you can get. And then this is almost unheard of. Just 1 week later, so we're September 19th, just 1 week later, that same area had been relieved, not just one, but two categories of drought. And that's extremely atypical because, you know, drought proceeds slowly and it improves slowly. So there's usually no rush to you know, change the conditions that quickly. But here's what had happened. We had massive rains during September, and they kind of ended, especially the second part of the month. The Duluth area actually had rains all month long. And this just 1 3-day event produced 4 to 6 inches of rain across parts of Minnesota. You know, of course, some of that water ran off, but it was good rain. A lot of it did go into the ground. And then on the right, you can actually see, it might be a little bit of a confusing graph, but that far upper right point shows what happened to Duluth in September. This past September, it was the second wettest and third warmest on record. So it didn't break any records for temperature or precipitation, but it was very, very wet and very, very warm. And what you are seeing on that graph is no year that was that wet or even close to that wet was anywhere near that warm, and vice versa. So it really stood out as almost a singularity in the Duluth record. So this is what we've seen. If we take apart two different parts of the year, and this is a little bit arbitrary, but so on average, Minnesota's precipitation is increasing. In if we look on the top, that's the growing season precipitation. And this is averaged around Minnesota. So you'll see differences if you look at different parts of the state. But this is generally the picture. There's a long-term increase in precipitation between May and September. That's the growing season. And that's shown with the red dots and the upper part of the graph. You can see in that red box on the right that the last few growing seasons have been very dry and below the trend line for sure. But now if you look at the bottom graph, that's the October through April precipitation. And what you see is actually slightly steeper trend line, so slightly sharper increase in precipitation, and also no trend during the previous few years, no trend, no similar deviation from what we had seen in the summertime or the growing season months. And when you look at those two pieces together and you think about all of the major dry episodes that we've had in Minnesota, they're actually teaming up to do some kind of funny business here. So this graph is just all those downward spikes are just dry years. And it looks like I may have missed one, but maybe not. All of those downward spikes are dry years, notable dry years. And you can think of this whole 2020 through 2023 period as kind of a dry period, right? It's been more than 1 year. It's been multiple years. But if we then look at how dry on a statewide basis 2021 was, when you include the exceptional drought, but also include the kind of bailout that we got from fall and then wintertime precipitation, what you actually see is that 2021 was just the 29th driest year on record since 1895. So in no way did it finish the year as extremely dry. It had extremely dry moments, but the wet period really bolstered it and kept it out of kind of historically low precipitation territory. And what we also see is that compared to other dry episodes, we appear to be in the wettest dry period on record. So no doubt about it, we've had dry growing seasons. No doubt about it, we've had significant drought conditions that have affected people's livelihoods and have affected municipalities. And we're not downplaying that at all. But when you look at just the dry years, you actually see the same trend. You could fit a line through those red circles and it's going to have slope to it because our dry periods are apparently getting wetter. And this dry period that's included some moments of really nasty drought is looking like the wettest dry period that we have on record going back to the late 1800s. Other things that we're seeing, I got some tips on how I did this on the left that you can ignore, but the temperature and precipitation, the wintertime temperature and snowfall have both increased across all of Minnesota. So going back just to the middle of the 20th century, those bars indicate days with heavy snowfall in Minnesota and 5 different first order climate stations. And you see some ups and downs, but generally for each of these pentads or 5-year periods, you're seeing these bars on average getting bigger, meaning more days with heavy snow. And meanwhile, our wintertime temperature, which is that red graph that's imposed over it, it's actually for the whole snow season. So November through April, those November through April temperatures have been going up on average too. So we're getting more snow more heavy snow, even as our temperatures during the snow season are increasing. And this is adding to some interesting combined trends. So back to Milan, where the 2010s were the snowiest decade on record, that was also the decade with the most thaw conditions during wintertime when it would snow. So starting to see some odd things emerge here. We're seeing more days with winter rain, and this is the Twin Cities, but we see this in Duluth. We see it everywhere, that days where there's rain falling, but it's wintertime, December through February, they've increased. Generally, they've essentially doubled in frequency. They're still not all that common, but they're increasing in frequency. And as we know from last year, when you have higher wintertime temperatures combined with the precipitation that's falling, you're either going to get rain or you're going to get very wet snow. Or in some cases, you'll get wet snow that's then topped off by winter rain. And those are extremely dangerous conditions for trees. We had wet snow crush millions of trees in Minnesota last winter. It was perhaps the most damaging winter to forests in a generation or more. And then we also have, structural damage from snow loads, things like that. I'm just going to breeze through the severe weather stuff, just showing that there's no real trend in the number of, if you look at the modern era, in the last 20 years or so, there's no trend in the number of severe thunderstorm and tornado warnings being issued by the National Weather Service. Uh, if you excuse 2022, which was an off the charts year for severe weather, there's no long-term trend towards large hail or damaging wind gusts either. These are hail sizes of 1.5 inches in diameter or greater, wind gusts of 70 miles an hour and greater. Both of these are almost guaranteed to do damage. And again, 2022 is a spike, but prior to it, there's no trend indicating no real increase. However, we've been seeing some odd behavior in severe convective weather events. We've had, in October of 2021, we had the farthest north latest tornado on record in Minnesota. It was across the boundary waters and went into Canada, and it was in October. I think it was October 9th, and it was a damaging tornado with a wide path that knocked down a lot of trees. And then 2 months later in December, we had 20 plus tornadoes recorded in the southeastern part of Minnesota, along with an outbreak of damaging straight line winds. And so while we can't say that there's an increase in tornado, severe thunderstorm, hail and high wind activity in Minnesota from these convective weather hazards, we can say almost definitively that across the entire region, we're seeing an expansion of the severe weather season. The severe convective weather hazard season has expanded into now fall and even early winter in rare cases. And on the front side, it's expanded backwards through spring and sometimes into late winter in rare cases. So we're seeing basically an expansion of the geographic and time ranges of those types of events. And the last thing is just these hybrid or emerging hazards like, wildfire, which I think, often is just thought of as coming from the combination of drought and heat. But I think that's overly simplistic because foresters have been documenting changes in forest composition for years and decades now in parts of southern and central Canada and the northern US, and changes in forest health. And some of those are related to just warmer winters, which are pushing trees out of their comfort zones. Some of it's related to changes in precipitation regimes, including precipitation intensity. But those factors then make trees more susceptible to pests and to mortality from things like drought. And that makes it easier for them to burn. And so when you've weakened the forests after decades of very, very warm winters, the kind of fires we had in Canada this year maybe aren't quite as surprising. And then that leads to degraded air quality as the smoke drifts into your region. These are kind of normal hazards, but they're becoming more likely. So there's always been fire. It's natural, but we're obviously appear to be at a time where it's going to start increasing in frequency. So to summarize all of this, I think we're experiencing the wettest period on record, even when you account for the dry years. I mean, I would never say that, 2023 is the wettest year on record because it's not. It's been a dry year. We're going to end up low on the graph again. But when you look at some of the other trends going on, we've continued to have more frequent and large extremes of precipitation, even when you account for the drought. We're, of course, warming rapidly. We've had profound changes in our winter temperatures or increases. All the models, we didn't get to a lot of the future scenarios here, but further increases in precipitation and extremes, warming and major heat extremes are all kind of on the way with more significant drought as heat kicks in. And just remember, we expect lots of ups and downs to continue. We're not going to get to a point where every year is like the year before. That's only a very simplistic view of the climate that's not accurate. So we're going to have cool years and we're going to have warm years. It's just that on average, they'll all be warmer than than the years that were like them in the past. And the same is probably true for precipitation. Severe weather season is expanding, and we just talked about wildfire smoke. So I guess it went longer than expected. And what else is new? But if you have any questions, I'll answer them. Thanks, everybody.
Yeah, thanks a lot, Kenny. That was a lot of good information and honestly, personally, a lot to unpack and just kind of chew on. So at this time, I'd like to open it up for questions. Just like to remind everybody that we do have the Q&A function there. I have a couple pre-registered questions, but it looks like we already have two here. Kendra asks, on the larger scale, how quickly are these increases occurring? On these smaller graphs, they don't look too drastic. The hardest thing I see is getting people to understand these increases are occurring abnormally fast because of human-related activities.
That's a good question. I mean, I think that it's a good question and a good point. Our changes are fairly subtle for the sort of overall climate. If you think about the way that precipitation has changed in Minnesota, on average, average precipitation has increased by about 10 to 15% over the period of record. So it truly, from just a pure magnitude standpoint, is subtle. And so you're not gonna, if we look at just southeast Minnesota, though, it's a bigger change. So parts of southeast Minnesota, average precipitation has increased by more like 20 or 25%, which is huge. And they've had big gains in growing season precipitation down there. But it's more subtle and even more muted as you get into parts of northwestern and north central Minnesota. So I agree. It's just that overall this increases the total amount of water that's coming out of the sky. And if you think about how much water is in an inch of rain, and then you multiply that by the 85,000 square miles in the state, you end up with billions of gallons. It's huge difference in the amount of water that just sort of is entering the system. So sometimes these really subtle changes actually have, they graphically, they are shallow trends. They're statistically significant because of their persistence, but they're relatively shallow slopes. But you have to kind of then think about what that means for other parts of the system. And I will say that the temperature trends in especially in winter are pretty extraordinary by global standards. Our winters are warming at a rate of about a degree per decade on average, and that's a 90-day average temperature. So, so we're averaging that 1 degree increase per decade over the entire 90-day period and then accumulating that through time. That's a much faster change than we see on average, on a global basis and other parts, or on an annual basis in other parts of the world. So some of our changes are very fast and some of them are pretty subtle. It's a good question.
All right. David asks, with these years of alternating dry and wet periods within the same year, what is the thought on the effect of this on aquifers, if any? And is there a thought on how we can keep more water on the landscape as a reserve?
Yeah, what? There are people who are better equipped to answer those questions than me. I'm a climatologist, and I don't want to veer out of my territory and step on the toes of groundwater specialists or hydrologists or soil scientists. So I'm not qualified to answer that. I know that these are conversations that people are having quite enthusiastically, and that's really all I can say about that.
We probably got time for one or two more. Kristen asks, are there things you think we should be doing here in Minnesota to prep for more potential drought than we're not doing already?
So I know that one of my colleagues leads the DNR's drought efforts as a kind of planning efforts, and it's hard because when they could be meeting and making plans, we get hit by another episode of drought, and then they just kind of go into response mode. I think that if I were planning a community or a watershed in any capacity, I would want to think about am I ready for any of these extremes? I mean, are we ready, for drought that even surpasses what we've had the last few years? Because it's certainly part of Minnesota's history. And as we get warmer, and especially if we start evaporating more water during the summer because we have more summer heat, that's going to become a bigger issue during dry episodes. But I also think you have to take the trends towards increased precipitation really seriously. Uh, and I think that tends to get underestimated the most. We're so afraid of losing water. We rightfully, want to make sure it's there and we depend on it. And so we kind of go into panic modes during drought. And then we take our eye off of what happens when you come out of drought. And I can tell you from looking at the climate record and talking with other climatologists, it's pretty common that 1 to 3 years after a major drought episode, you have flooding that is up around historic levels. And so whenever this dry episode ends, I'm concerned that we're also going to come out and have, something that we're not ready for on the other side of it. So I recommend familiarizing yourself with the best practices for both water excesses and water shortages.
And I think we're pretty much out of time, but one last question here. For conservation in working lands connected to drainage systems, how might this sizable increase in water impact the drainage systems and waterways that are connected? Minnesota River, Mississippi River, etc.
Again, I will say that question goes a little bit out of my expertise, because so much of how water behaves once it hits the land has to do with, saturation of the soil, composition, other things that maybe aren't even climatological, the timing, what kind of regime were you in, is it all coming at once, or is it coming sort of distributed over a long period of time? This all gets into complexities that I'm just simply not qualified to address. I think the take home though should be more water falling on the land. We often forget this part. That's the really basic side of the equation. And I spent a lot of time in the last decade just trying to point out, like, it doesn't really matter. If you just look at the one side of the equation, there's no way to dispute that more water is falling. And so in theory, that would mean, more water kind of everywhere. But exactly how it behaves, that's way beyond my expertise.
Thank you very much.
Yeah, anyone can ask questions to me. Oopsie, don't ignore that.
You clapping. Well, let's give Kenny a big
Let
round
me
of applause for everyone who's still here. There's
stop sharing.
reactions down at the bottom of your screen, hopefully, but really, thanks a lot for taking the time and explaining this to us more in detail, Kenny.
Sure. Yeah, I'm happy to. Also, I'm just putting my email address in the chat. If anyone, I'm sure you've shared it, and anyone can contact us and ask a question. If you're happen to be on the St. Paul campus, you can come in or schedule time to come in and talk to us. I'm a state employee, so I have a state email address. It's right there. You can also give us a call. You can call me, putting my phone number.
Nice. Thanks. I did include a link for the State Climatology Office, which has that phone number too. So, and a lot more information if people want to dive deeper.
Great. Yeah, the number I put is a direct line to me. So we have a few different ways of getting a hold of us.
Everybody grab that number. You'll get all kinds of calls now.
Usually I get about 2.
Okay.
Usually it's 2. You get a lot of threats. People say, "Oh, I'm going to call you right away," and it's usually about 2 people. But yeah, anyone can call, and we'll try and help. And if I can't answer it, I bet you one of my talented colleagues can. So
excellent. Well, thanks everyone for being here. Not everyone is still with us right now, but we did have a really big audience, and we appreciate the update and the information, and we can get it straight. Now, what's what with Minnesota's climate?
Great. All right. Well, thank you very much. It was good to be with the Twin Ports again.